All right, we notice here that we have an x on both sides of the equation, and this one's stuck under a radical, so we got to get rid of that radical first. So I'm going to go ahead and square this side and square this side. And then on the left side of this equation, that means we just have an x minus 6. And over here, when we FOIL this thing out, it's going to end up being x times x is x squared, x times negative 8 is negative 8x, and then negative 8 times x is negative 8x. Negative 8 times negative 8 is positive 64. And these like terms will combine to make x squared minus 16x plus 64. And it's a quadratic, so we need to get one side equal to 0. It'll be easier to kind of get rid of this stuff and put this over on the other side of the equation. So I'll subtract an x and subtract an x. I'm going to add a 6 and add a 6, putting like terms by each other. This left side now is 0, and this right side will become x squared minus 17x plus 64 plus 6 is 70. And I promise you these will be factorable. You can use quadratic formula if you want to, but I'm going to make them factorable. Two things that multiply to make x squared will be x and x. I need things that multiply to make a positive 70, and I also want the inner and outer to combine to make a negative 17. So 7 and 10 is the first thing that comes to mind, both negative. Setting each of these equal to 0 gives me x equals 7 or x equals 10. And I've got to check these both now. So basically, if x equals 7, I'm going back to my original problem. And I'm going to, so before I square it or anything else, I'm going to go ahead and plug in a 7. So it's going to be the square root of 7 minus 6 equals 7 minus 8. This side becomes 1. This side becomes negative 1. Those are not equal. This is not an answer. If x equals 10, we're going to get the square root of 10 minus 6 equals 10 minus 8. This side becomes the square root of 4. That's equal to 2. This side also is 2. That's totally true. So this is my only answer.